Separating mixtures using multiple methods. Separate a mixture of 3 or more solids. Mixture of salt, tiny beads and pencil shavings. We can use 2 methods. Method 1, hand picking. This will separate the pencil shavings. Method 2, sieving. This will separate the beads from the salt. Next, separate a mixture of 2 solids in a liquid. Mixture of sugar and sand in water. Method 1, sedimentation. This will cause the sand to settle down in water. Method 2, decantation. This will separate the sand from the sugar and the water. Method 3, evaporation. This will separate the sugar from the water. Students, now let us learn about the steps to choose the correct separation method. In the previous activity, what were the 2 separation methods that you used to separate the given mixture of pencil shavings, salt and dal? Why? We used hand picking and sieving methods to separate the components because the components were of different sizes and quantities. So we used the hand picking and sieving method. Useful properties to choose a separation method. So to choose the correct separation methods for any given mixture, we have to consider a few properties of the components in the mixture. Let us see what are the properties to be considered. First, the type of mixture. Second, the size, weight and quantity of different components. And the third, the solubility of different components. Using the example of the mixture we separated in our previous activity, let us understand the steps followed in choosing the correct separation method. A mixture of pencil shavings, salt and dal is a solid-solid mixture, 2 or more solids mixed together, or solid liquid mixture, 1 or more solid mixed in a liquid. So which one is correct? See, it is a solid-solid mixture, 2 or more solids mixed together. Then we can compare the particle size or comparative weight of the different components. Which one did you consider for the mixture of pencil shavings, salt and dal? Why? Size of particles or weight of particles? Which one did you consider? The size or weight? See, we consider size of particles. Yes, we consider the size of particles as the components of the mixture were of different sizes. So we chose size of particles. Based on the particle size, which method did you choose to separate the pencil shavings? If the component is big enough to be picked, use hand picking. If the component is too much and has fine particles, use sieving. If the component is lighter from the other components, use winnowing. If the component is stuck to the other component, use threshing. Which method will you choose to separate the sand from the mixture? If all the solids are insoluble, check which solid is heavier or lighter than water. First, separate the heavier solid by sedimentation and decantation. Then, separate the lighter solid by filtration. If one solid is soluble and other is insoluble, first separate the insoluble solid by sedimentation and filtration. Then separate the soluble solid By evaporation. Which method will you choose to separate the sand from the mixture? Why? See, if all solids are insoluble, what we have to do? First, separate the heavier solid by sedimentation and decantation. So, we can separate sand from the mixture using sedimentation. And decantation method, as sand is heavier than pencil shavings. Method 1. Sedimentation and decantation. This will separate sand from water. Which method will you choose to separate the pencil shavings from water? See, then separate the lighter solid by filtration. We can separate pencil shavings from the mixture using filtration method as it is lighter. See, after method 1 of sedimentation and decantation, method 2 is filtration. See, this will separate the pencil shavings from water.